So, number one, what's the interval described by 0.35 plus or minus 0.07? You're just going to add and subtract. Just get you used to the format, the mathematical format of that. So you're going to get the high side and the low side, and then make sure you put them as interval notation. And you're done. See how easy that was?
That's super easy.
Super easy. The next one is the same. It's a 0.65 plus and a 0.65 minus. I got, let's see, 0.54 on the low side and 0.76 on the high side. I noticed on a lot of homeworks that they didn't have the parentheses around it, so make sure you do that. That's an important part of it. So margin of error, there's a vocab term there. And that basically means that's the plus or minus part of what we just did. So it means 0.57 plus or minus 0.03. As an interval, subtract it, you got 0.54, and add it, and you got 0.60. It was almost a year ago, a little more than a year ago, and it looks like Biden's going to win the Democratic nomination going away. Notice at the bottom, the margin of error was actually there. So Biden, he would have been between 0.26 and 0.36. Sanders 0.18 and 0.28, and then these two who got knocked out, 0.03 and 0.13. The logic of a confidence interval then. The p-hat is the point estimate. It comes from the sample. It's whatever the sample says. The 2 is the part that's the 95% confidence. If we wanted a different confidence, and we went over this before, you have to look up a different number. But, you know, this is prep stats. Don't have a graphing calculator. I'm pretty much going to leave it at 2 and 95%. Also, this whole part here, so including the 2, that's what you call the margin of error. I wrote this problem before Kobe Bryant died. Sad. Okay, so first 2 games of 2009, 2011. I chose that because that was the last year that the Lakers won a championship. So he made 17 out of 45. That is your p-hat. That's the point estimate. See, I worked this out ahead of time. As a decimal, that's 38%. So not a very good start to his season. But that's a small sample. It was only 45 shots, right? Well, at that point, after just 2 games, we could calculate his confidence interval. So we would start with the sample number, 0.38, 2 times, so there's that p-hat again. That's the same 0.38 that goes in the standard error formula. And of course, 1 minus p-hat, that would be 0.62. And the sample size is not 2 for games, it's 45 for number of shots. Okay, so the standard error is 0.07. And when you multiply that by 2, that means the margin of error is 0.14. So we do the same thing we did on number 1 and number 2. We add and we subtract for the plus or minus, and it gives us the interval 0.24 to 0.52. Somewhere in that interval, we would feel that we have a 95% confidence that his true ability, you would say, is between those 2 numbers. Now, the reason also I chose a previous season is because then I could give you what his actual statistics were for the whole season, which I'll do on number 9. Okay, so 7 is just a review of how do we interpret it. We are 95% confident that the interval of plausible values from the low side of 0.24 up to the high side of 0.52 contains Kobe's ability to make a shot during the 2009-2010 regular season. It's a pretty wide interval. If you shot 0.24 as a player, you probably would not be playing. The coach would sit you down. But if you shot 0.52, I mean, you're an all-star. You're one of the greatest players of all time. What do you think will happen to the width of the interval? This is number 8. If you use Kobe's performances from the entire season instead of from just the first 2 games. Will it get wider? Will it get narrower? Or will it be the same? The games were in the denominator. What happens to a fraction when you make the denominator bigger? Gets smaller. So you see, it wouldn't get wider. It would actually get narrower. In other words, the guess would get better, right? The more data you have, the better your guess becomes. And we're going to see that. So we'll get narrower. We're going to see that when we do number 9. Okay, during the entire season, Kobe took 1,569 shots and he made 716 of them. So this number, even though I'm going to call it P hat, is more likely just a P. It's a parameter from a population, the whole season being the population of shots. And that turns out to be 0.46. So quite a bit higher than just after 2 games. After 2 games, it was 0.38. Okay, so let's run through the formula. You have 0.46. There's our point estimate. Plus or minus 2. 2 is because of 95% confidence. The square root of the 0.46. And then 1 minus 0.46, which is 0.54, over 1,569. That's the total number of shots. And this turns out to be 0.46 plus or minus 2 times 0.01. So his standard error was 0.01, but then the margin of error is when you go ahead and multiply that together and you get 0.02. So look how narrow that makes the interval. It goes now from 0.44 to 0.48. Compare that answer to the answer we got in number 6. More data makes a better guess.